Howdy folks, Mr. Reed here, and welcome to One More Question. So today, I'm going to be taking a look at an equation involving some exponential statements, and it's going to be a little more of a doozy. So it's going to look kind of icky in terms of its final answer, and that's entirely okay. But it's going to be more involved. We're going to have to be a little bit more careful. So if you're looking to apply logarithms to solve an equation that has exponentials in it, you want to do it at kind of a nice solid medium level, you're in the right place. So let's get to it. All right, now I'm going to write it down again like I always do. Maybe I should start writing them down before I actually get started. I don't know why. I like to do it kind of in the flow of things, but it is what it is. So you have to watch me write it down again, and we'll see where it goes from there. So we have some choices. We could take a base 3 logarithm to both sides of this equation, really tidy up the left, kind of leave the right-hand side hanging. It's going to be a mess. We could take a logarithm base 4 to both sides of the equation, really tidy up the right, leave the left-hand side a mess. We could take our favorite logarithm base, say a natural logarithm. I really like logarithm base e. It's kind of my thing. So I would take a natural log of both sides of the equation, leave both sides a complete mess. Any of those options are actually pretty equivalent. The logarithm is base 3 and 4 look like they're a little bit tidier, but they're not actually that much different. I'm going to choose to use one of those ones, but I would really encourage you to try this out with like a logarithm base 10 or a logarithm base e, so a natural logarithm, and just kind of see if after you get your answer, you can evaluate it to be the same as whatever we get using the base 3 or the base 4. So you'd have to punch it through your calculator very carefully, correctly, and see how they compare. All right, so I'm going to go with logarithm base 3. So I'm going to apply base 3 logarithm to the left-hand side of the equation and a base 3 logarithm to the right-hand side of the equation. What that's going to allow us to do is make a really nice statement on the left, because the base 3 logarithm applied to the base 3 exponential, inverse functions cancel, so you get x plus 1. On the right-hand side, we're instead going to do something a little bit tricky. So we are going to say that in this particular example, the 4, that is the exponential function's base, since it's always going to be a positive value, that 4, when we take the exponent and move it down to the front, we don't have to worry about whether it's going to affect the positive or negative of that 4. It's a 4, so it stays positive. So what I'm going to do is I'm actually going to take this expression and use the logarithm law that allows me to take it down and write it as a coefficient on the front instead. So when I do that, I'm going to get 2x minus 3 down front. I'm going to put it in a bracket because it's the whole expression that gets moved down and multiplied. And if I mistake that for just the 3, the negative 3 multiplying onto it, and forget about the 2x, then that's going to be incorrect. That's still multiplying log base 3 of 4. Now, what I need to do is solve this thing for x. Now, my x is actually inside of a bracket that's multiplying the log base 3 of 4. If I try to remove it without multiplying it by the log base 3 of 4, that's not actually what's on the right side of my equation. I always find it better to expand the expressions and then move over the pieces that you need. So I'm going to leave the left-hand side as just x plus 1 for the time being, but I'm going to multiply 2x times log base 3 of 4 and the negative 3 times log base 3 of 4. So we would get 2x times log base 3 of 4, which I guess I just said out loud, which is funny because it's the multiplying is actually just stuffing it on the front as a coefficient, so it doesn't really, you didn't really do anything other than write them together. But it does distinctly make two different terms there. One of those terms has an x in it, the other one does not have an x in it. So I'm going to start separating my things that have x's and my things that do not have x's. So I get x, and I'm going to move over my 2x times log base 3 of 4, and I'm going to take the 1 and subtract it from the left, subtract it from the right, so I get negative 1 on the right hand side now, and I also have this minus 3 log base 3 of 4. Now, what we can do on the left-hand side is say I actually have an x in common in both of these terms, so I can factor it out as a common factor. So that common factor is just x, and we're going to be left with 1 minus 2 log base 3 of 4 is equal to, I was going to say, I'm going to factor the negative out. I don't know. It doesn't really matter, but I'm going to do it anyway. So there we go. Last step, I'm going to divide both sides by the big clumpy term that's next to the x right now. So I divide the left-hand side by that, it cancels. I divide my right-hand side by that, and it is going to just appear in the denominator of that expression. So it would be that over 1 minus 2 log base 3 of 4. Now, you might really not like that expression at all, and to be honest, you could probably fiddle around with it a little bit to see if you can make it look a little bit different. And depending on whether you take a log base 3 at the beginning or a log base 4 or a natural logarithm or whatever the case may be, your end answer is going to have a very different look to it. Now, having a different look and having a different value are two very different ideas. So if you do try this using a natural log specifically, then you're going to get something that looks quite different here. What I would advise that you try is maybe doing that as practice. Put this one that we found here in through a calculator, knowing that you have to do a change of base depending on your type of calculator. So if you are doing a change of base, this expression of log base 3 of 4 could be written as ln 4 over ln 3. So if we put that in for that and we put it also in for that, then you could try to put that value through your calculator, get a decimal approximation to this whole x value, and then put it up against what you got using one of the other methods. Hopefully you enjoyed that one. I don't know, maybe enjoy is not the right word. I would enjoy that one because I like this sort of thing. Hopefully you found it useful. And if you did, like, subscribe, and as always, please take care, folks.